okay, maybe we'll do something rare and start right on time. But this is recording, so if anyone misses the beginning, we'll have it up. Thank you all for taking the time wherever you are to join us. I'm Amy West, Program Manager for Synchro, and I'm joined here by my colleague from Synchro, Jason Adelars, who's our Technical Manager, and our panelists from Suburban Marine, Jacob Sloss. So before we start, I'm going to give you a little bit of background of why we are having a webinar. Synchro, which is not only this group of logos showing our marine institution partners here at the top and our funders at the bottom, aims to sync the needs of marine stakeholders. And we focus on scientists, engineers, and those who are using the information collected by the ocean technology. But those users don't always get a lot of attention. And so this webinar series is helping bridge that connection. Because ultimately, developers want to design something that incorporates user needs. And so that's often harder to do than it sounds. So for some quick background, Synchro, we primarily focus on ocean observing tech that is still evolving. It's coming into the market. And we do this in a few ways that are listed here. But it's the first one that I'm going to talk about, which is boosting access to testing facilities and testing and evaluating your prototypes. So we provide a no-cost access to testing facilities with our partners who you saw on the first slide, all of those marine institutions. And they're here in Monterey Bay and some up in British Columbia and Pacific Northwest. And then part of the deal is that we provide technical support and also travel support to allow you to test and evaluate your equipment. So, whether it's on boats or piers or the need for test tanks, we also provide webinars like this one, and we have a public portal to publish those results for potential users to access. So Suburban Marine is one of our testing applicants, and it's our inaugural webinar to spotlight their system. So more of you know about it and then can provide feedback directly. So I'm going to stop sharing just a tiny bit of housekeeping. There's going to be 15-ish minutes of presentation, and then the last bit will be time for questions. So if you can just put them in with the Q&As, there should be a Q&A button there. You might use the chat. And then with that, I would like to pass it over to Jacob, who will present on their Luma 360 system, a integrated marine monitoring system.
Right. Thanks, Amy. Let me get my screen share going. Okay, is that working? All right, yeah, thanks. So thanks, Amy. I'm Jacob from Suburban Marine, and I'm here to talk to you about our Luma 360 MDA system. So we've developing new products in the maritime monitoring space. Trying to make new radar technology, new camera systems, and just trying to kind of push the bound, trying to make some new systems in this space available to ports, harbors, and conservationists, just to increase the amount of data that we can collect and observe about the marine environment. So briefly about us, we're about a 6-year-old company. We started out doing engineering consulting, mainly in aerospace, ranging from working on little 1-pound quadcopters up to full-size 5,000-pound manned helicopters, mostly doing autonomous systems work. We also have a specialty in camera systems and distributed data and acquisition systems. So kind of just a lot of different embedded software and hardware work. And so recently, in the last 2 to 3 years, we've started entering the MDA space, working with a few partners, developing hardware for their marine domain awareness systems. So what we're trying to do that's different is we're trying to make mesh networked small nodes, which lets us place a lot more sensors, a lot more places in the nearshore environment to help fill in coverage gaps in from the big single point fixed systems. So we're trying to do mobile systems, we're trying to do lots of small systems, and we're trying to make them talk to each other so that they can like work together to get a much more cohesive picture of a much larger area, like the entire coast or an entire country. So our product right now consists of camera and radar and AIS nodes. Um, so you could have one site with more than one sensor. You could have sites with only one sensor. And just this helps reduce cost. It helps reduce size, weight, and power. It helps make it easier to install. It makes it, there's also a lot more places to put these systems since they're smaller. It's a lot easier to install them. We don't need access to a 50-foot tower with a keep out radius. Um, so we're really trying to get these systems more places. So you're these um just these big like these big systems with these big radars are just too expensive to install a lot of places. So that brings us to the Synchro project. So we're very grateful to Synchro and Bari and Stanford for making this project possible. So this was our pilot system with Synchro. So I think it goes about 3 months from concept to install. So this is highlighting our AIS receiver at Hopkins Marine Station. This was a very simple install because it didn't require any roof penetrations. It's just a collapsible antenna mast with like with counterweights and with only a single antenna on the same mast as the enclosure. So this is a way to get a very quickly deployed MDA system that can just pop up. And if you have some short-term observation you need to make, we can quickly place a small system to look at a specific area. And then if you're done, you can you can pack it up and move it somewhere else. And it's just it's a lot more flexible. So looking inside the box, so we have an AIS receiver with an internal computer. Um, we have LTE, Wi-Fi, and Ethernet uplink. For this system, the LTE antennas are internal, which helps make it easier to install. And it helps us limit the number of penetrators for connectors on the outside of the box, which helps keep the system reliability higher. So why AIS? So AIS is one of the cheapest ways to get tracks on vessels the furthest away. We can get hits as far away as 200 miles, and we can do it for about 1/10 the cost of a radar, like the cheapest radars. So we don't have problems like radars can only really see out to the radar horizon. We're seeing past the radar horizon with this AIS system. We're getting reflections and stuff. So it's a very cost-effective way to get very long distance tracks on on these large vessels, on cargo ships. Since most of these vessels have a transponder, it's a fairly simple way to get some basic track data on how many vessels are in this area, where are they going, where are they coming from. So the risk with that is, since it's transponder based, if a bad actor is up to no good, they will just turn off the transponder. So it is good for tracking people who are following the rules. It's also good when you pair it with other detection systems like a radar, because then we can starts to do things like, oh, we have a radar track correlating to an AIS track, and then we suddenly lost the AIS track but kept the radar track. We can start to like find more people that way. It's interesting. So this is now looking through our data view. So it's a web-based map interface, and we can see the AIS tracks here just for a quick, last couple hours on a Saturday last week. Um, so this helps. This is so more interesting though is selecting regions of interest around like this conservation area. So this lets us highlight all the vessels that entered this area, and then it lets us show where they came from and where they're going to. So it seems like most of the traffic's aware of the MPA. There's one little guy here who's kind of hanging out in the corner, but it doesn't look like anyone's fishing. We can generate other reports. So this shows the total time that a given vessel ID spent in the zone. And we also can do statistics on vessel speed. So like we can show that the average speed in the zone was high. They're not just parking there. They didn't spend like hours in the zone. So there's no reason to like send an automatic alarm to someone. Um, if you click on a vessel, you can see the speed over this entire course. This is potentially interesting for carbon credit incentives. So some people are interested in tracking vessel speed for vessel speed reduction, which is um, good if as ports start to do incentives for reducing carbon credits, we can actually audit and automatically generate reports about, which vessels are which speed as they're approaching the port, where they reduce speed for an entire over their, entire nearshore course. And then lastly, we also are integrating radar data. So as I mentioned earlier, you can always just turn off the AIS transponder, even though it's illegal. But if as we are trying to fill in the gaps in the sensing environment, we can overlay radar, and we're working on algorithms to automatically identify vessels and classify them from the radar return so that we can correlate them with their AIS beacon. And so this will let us do things like hand off vessels between AIS and radar sites, and it'll let us do things like identify tracks that used to correlate to an AIS beacon but no longer do. And usually so usually those are worth sending like an alarm to an operator over. So we're very grateful to our partners at Marine Monitor who gave us test and development access to their point bonita radar system for this. So talking about our network, so our network backend is a mesh IoT network. This lets us avoid single points of failure, and it lets us reduce latency. This is very valuable when we start to have lots of low-cost systems, and we can do things like have backup network links. And as we start to go global, it lets them talk to like nodes nearby them in their side of the world, and they don't have to dial all the way home to like the other half of the world. Our data is encrypted and protected in transit, so we take cybersecurity seriously. It lets us be last mile agnostic. We don't have to coordinate. We usually don't have to coordinate with our end sites, IT departments. They can stick us on the guest network, and we're able to just dial out. We can run over Starlink and over LTE with CGNAT, and we can kind of just self-assemble the network on our side and move all the data. So as I mentioned, cybersecurity is very important. Our devices, we're adding hardware keys to all of them. So this keeps it so that the login keys on the end devices can't be leaked. So if a hacker, takes if there is a physical attack on the device, they can't get the keys out of it to like clone it and duplicate it and potentially try to eavesdrop on other nodes. So this is very good at protecting unauthorized access both physically and over the internet. And we also have provisions for secure time synchronization. We have signing keys with NIST that they keep us from getting our clocks spoofed. And this is very important when we're talking about a sensor network, because it's not just good to know where someone is, we have to know when they were there, so that we can timestamp the AIS data and timestamp the radar samples and actually, like, that's how, so we can show trajectories. So our upcoming features for this year are, integrating the radar as a first-class system, doing the automatic handoff between the AIS nodes and the radar nodes, and then also integrating some AI models and cameras, which are available that can do things like classify vessels into different classes for, like, powered or unpowered, and also they can detect marine mammals, because there's been some interest in marine mammal interactions. And then we can also do things like as the vessels get closer to the nodes, we can do things like take pictures of them. And so this really kind of shows the advantage of multiple sensor systems is these sensor systems excel at different ranges. So like the AIS beacon can give you a course track over 200 miles. A radar site can give you a very fuzzy pixelated view of a boat from tens of miles. And then once it's within a mile or so, a camera can directly take a picture of a vessel and try to get a picture of its like name of the nameplate on it, for positive identification. So these systems really work better together than apart, and they sometimes work better in different places than other systems. So like, the AIS receiver might be really happy really high up, but the camera wants to be as close to the beach as possible, and we can make both of the systems smaller and install them the place they work the best, and then let them synergize. So what's next is we're looking for deployment opportunities. We're always looking for different pilot projects with different sensors. We're interested in deploying radars and AI cameras. We're always interested in integrating different payloads too. Custom sensors are fun. We're interested in getting our data out into your system, because I know there's a lot of existing GIS data systems that everyone's always using. So, we're very happy to export our data. So, just so thanks for listening. Send us a note with any questions, or if you want to chat about sensors, we're always happy to talk.
Oh, thank you so much, Jacob. There were so many things I learned. I didn't think about carbon credits and the potential to audit. So mind blowing. Anyways, we want to hear from you. We want to ask you a question, like want you to pose any of your questions, and even the like nitty gritty. Jacob is your person for that. And simultaneously, we're going to be launching a short poll. There's just 3 questions. You'll need to scroll to see them. You may not know, may not be obvious, but don't be shy. Throw out any questions in the chat, Q&A, and Jason is going to be following up with that.
Okay. I see a question from Fred, asking if there's any difference between 2 different signals. I'm wondering if that's the radar versus the AIS signal.
In terms of like frequency, or like they are very different. So like the AIS is very long wave and it goes very far, and it can reflect off of like the atmosphere. And then the radar is very directional and relatively short range and relatively high absorption.
To clarify, he said AIS-A versus AIS-B.
There is a difference. I think we're only on A. Let me see. Actually, we are a dual channel receiver. I think we can receive both A and B, but we only receive, we don't transmit.
Okay. I can certainly attest to installation of the system was quite easy. They were able to ship us a unit just in the mail, and it came in a couple of boxes, and 1 to 2 people. We were able to install it in about an hour, and Jacob was seeing data pretty much immediately, and it was just the matter of plugging it into a wall port, and we were seeing data. And so as far as a whole user experience, it was quite easy to set up.
Yeah, and Fred was just pointing out that I guess the ASB is much less info than the ASAA, so AISA.
So I've got one question here is can this unit detect soft targets like kayaks and boats landing on the beach at night or something like that? You know, thinking in terms of like those, you know, those smuggling boats or something.
Mhm. Yeah, and so that's really what the camera system is better at. So the like the FLIR M400 cameras with the long wave infrared, they're good at detecting humans and small boats. And so not so much the radar and not AIS, but camera systems, yes. And those are also the systems that you want to have right at the water.
Mhm. Another question is, are there any simulations of what an optimized mesh network might look like?
Um, So not that we've done, I know for like radar path analysis, there are tools you can use to like place radar sites in a virtual environment, show the radar, you know, RF, like there's like RF propagation tools you can use to show like how far will this radar be able to see, and will radar A interfere with radar B. So that is a thing you can do to optimize radar placement. For cameras, it's a little bit easier because you can just kind of calculate, you know, I have this focal length lens. So if I want to see a target yay big, I need to put them this far apart. So that is definitely a thing you can do. And you probably, if you're talking about, you know, doing an install for the entire California coast, then you would be using those tools to help you guide placement. Because radar is very sensitive to terrain as we start talking about trying to get it out to its full range. So we definitely need a terrain or rare placement tool for that.
Just a reminder to for those to just finish the poll, and we'll end that. Gives a little bit of information helpful for Suburban Marine as well. Look who's on the call. Oh, just one more question there.
Yeah, another question is, can you talk a little bit about the cost savings of your system versus the like what an existing AIS system would be? Is it a, you know, a tenfold decrease, or, you know, I know your system's probably built to order, and it might come in different flavors, but if you can talk about cost savings, that'd be great.
I don't have any quotes for third-party systems, unfortunately, to give you hard numbers. So I would say email us and we can talk, you know, figure out the exact pricing differences.
Another question is, are there any machine learning algorithms for differentiating between marine species or different types of vessels that are like already exist?
Yeah, so so to clarify for the AI system that we're looking at, that was from a third party available commercial off the shelf. They were identifying about 20 classes of things. I believe they had a single class for all marine mammals, and they had a couple classes for different types of vessels. So they were kind of combining, they're basically sorting every type of boat into like 3 or 4 options. And they said that they could potentially, with more work, they could add more classes. So if you want to start differentiating different marine mammals, it's just a matter of training the model more, and then we can start adding more classes to separate out dolphins from whales. And if you were looking, trying to separate out specifically like fishing boats from, passenger ferries versus just them both being powered, then that is possible. Just they are not currently doing that yet.
There's one more follow-up with Fred as well. Just wondering what band radar you're using.
1 second.
Okay, I'm closing the poll. Last minute, last second to get in your
Expand.
expand. Okay. We actually have a few more minutes left. If anyone has those pressing questions, obviously you can reach out to Jacob directly at sales@luma360.com. But also, I don't know if you can see all the results, but we had a good mix of folks today. Okay, I think oh no, we've got one more. Oh yeah, I wanted to point out, first of all, Jacob, there's a note, so Pat, sorry, you were the first to reach out there. There's just a note about the Soquel Canyon, as a zone. It's obviously not a cordoned off space, so you can hang out in it. But just a future note, I'll copy that and make sure Jacob has it for future presentations, that you can indeed loiter there. And just a note from Fred that the Naval Postgrad School has run an expand in the past at the sewer plant in Sand City a number of years ago. Oh, one more question. Oh, wait.
Oh yeah, so sorry, I just typed it.
No, that's great. Thank you. You got it.
So this AI assist. So the question was, does it need to be hardwired? So this deployed system was wireless with redundant links over Wi-Fi and LTE. It also had an Ethernet port, but we didn't use it.
Maybe to add to that question is, what about for power? Are you have a model that can run on solar, or does this have to be plugged into a wall port?
Yeah, so this system was 120 volt, or actually I think it was 100 to 240. DC input's easy, power over Ethernet's easy, solar is relatively easy.
Okay. Do you know, I guess it depends on the unit, but how many watts is the unit on top of the Hopkins Marine Station?
I think it's less than 25,
25
maybe less than
watts.
10.
Yeah.
LTE draws a little bit more power than Wi-Fi does, but
So fairly low power. That's pretty good.
Power is always an issue in the marine environment. We are going to, not only did we start on time, but I think we're going to end on time. If you have any last questions, throw them in. And if not, I just want to thank everyone for the half hour of your time today and participating. I don't know if Zoom will send you a recording of this, but at the very least, we'll have it up on our website and send out an announcement later, should you need to refer back to anything that was demonstrated today. Thanks for being here, and we'll see you in the next one. Not sure what it is, but within the next month. Oh, thanks everyone, and thanks for your comments and questions. Okay, have a lovely day.
thanks.
Bye.